Good evening, sir.
Evening.
Good evening, sir.
Good evening.
Today is
So
Tarun's
today-
birthday and he didn't join yet, sir.
Who?
Tarun,
Okay.
I thought you were gonna say us.
I wish.
Someone's birthday is today or what?
Today is
Yes,
his,
sir, it's
He
today's.
came in colors and everything, but didn't come to class.
He didn't invite you all?
No, sir. He
I
on
mean,
Saturday,
he didn't
sir.
invite yet, but I think he will.
He invited.
He better.
You live nearby.
I mean, they live nearby. I'm not that close.
Sir, I'm the father, sir.
Oh,
Okay.
okay. Then I take
Closest.
back what I said.
Okay, good.
Yes, sir.
So let's start.
Yes.
New chapter.
No, we
Yes.
didn't finish that.
Yes,
Oh, we
yes.
finished that chapter.
Yeah, that is
Yeah.
done.
Oh
Ha.
no, I shouldn't have left.
Ha. We took advantage.
You
of
know
that.
what? You know what sir told right after you left?
What? Please, sir.
No.
No, he's like, now let's use this precious time with something like because Nitish left. It's like very precious.
We took advantage of your absence.
Yeah.
But anyways, you can see it in recording, no problem.
He glitched after that. What happened to him? His video stopped.
He was still in shock.
Okay. His video is actually stuck.
He was
Yeah.
still in shock.
I thought he was just stunned. That's so. That smile. That
It's so weird.
sir, look at Nitish's video. Sir. He looks really weird.
Okay. You can see the screen.
Sir.
So chapter name is rectilinear figures.
The most random name I heard.
Will be a long chapter, probably 3-4 classes. And that's why we are taking it in the starting.
Sir, not
Other
as long
chapters?
as logarithms and compound interest.
Yeah, not as long as that. But after that, other chapters are very small. So no problem. Okay.
Sir, in our school maths book, we have lesser chapters, sir. This book has 28 chapters, but ours only has 20.
Which book
What book
you are
there?
using?
Like, we use ML Agarwal book.
Can you
And
tell
sir
me what
is
you were
like,
doing, sir?
We started a new chapter.
Hey, you use ML Agrawal.
yes, sir, in
Yes, sir.
school.
What? Sir? I don't
Okay.
understand what ML or Grohara.
Day.
It's not a scientist name there.
Day. It's
The maths textbook there. It's the maths textbook name.
Oh,
the writer's name.
No,
Problem.
it's the
So
company's
I'll
name.
do one thing then. I'll use your ML Agrawal thing. But you know, in your
there's an answer
ML
key behind, sir.
Agrawal,
Don't, sir.
huh?
There's an answer key behind, sir. Don't use our textbook, sir. Our textbook, everything. Some of them are impossible. Some of them are
Day.
really
The
easy.
solutions for this book also.
Yeah, but I don't have
Sir,
the.
sir, don't
I
use
have
our
them.
books, sir. The
I
books
don't-
the book we use has really simple questions, sir. The
So
ones
some
you
of them
do
are
are
simple.
really
Some of them
Sir,
are
challenging.
yes, but I'm telling this because like this rectilinear
Okay, I
figures
get the point.
chapter and all is not even there in this book.
No, it is there.
Hey,
No,
Pongal,
sir.
doesn't
It is-
matter, da. We finished
is-
like term 3 portions like long
Sir,
ago. We
actually,
have nothing else
we
to
covered
study.
everything in the book. We only have statistics in the ML Agarwal book. Everything else we covered.
Yes, sir. So might as well just do this, sir.
So I don't know what rectilinear. You didn't say anything, sir. Right when you said what happened yesterday, I left. Sir.
nothing happened. Don't
No,
worry.
what happened yesterday? So something he said something you said. Sir.
Yesterday is gone. Yes.
Today
You
is
don't want to
happening.
know,
Tomorrow will
You
happen.
don't want
That's
to
it.
know, Nitish.
See, okay,
So we can continue.
we start rectilinear figures. Okay,
Yes, sir.
so rectilinear figures, first understand some basic meanings. Rectilinear means along a straight line or in a straight line or forming a straight line. Okay, any figures who form straight lines, they are called rectilinear figures. For example,
That's not a rectangle.
Sir, any closed figure which has a straight line.
okay,
No, has
it
all
is,
straight lines. All of his lines are should be straight lines.
yeah, okay. So generally we are going to classify, but generally that's how it is put. A plane figure which is bounded by straight lines is called a rectilinear figure.
Yes, sir.
A plane
So
figure is
this,
like
yeah, plane figure means which is drawn on the paper,
okay.
Any shape.
which is bounded by straight lines is called a rectilinear figure. So see, this red one is not rectilinear.
Yes, sir.
Okay. However, this one, if I extend it in both directions, this is a rectilinear figure,
No,
but
but
it's
it's not
not
close.
bounded. Yes, it is not bounded. So bounded in the sense,
They should
bounded
be
by
closed.
rectangles. Yeah, closed means you don't have infinite area. So a closed figure drawn on paper, bounded by at least 3 line segments, is called a polygon.
But what you drew there as infinite
Area.
area, sir.
Yes.
So, but how is it rectilinear?
It is bounded by a straight line, no? This side
So, but there is no
and
end.
this side. Yeah, that's what I'm saying. It is not bounded.
So it's not rectilinear.
Bounded by it is bounded by lines, but it is not bounded by area.
Yes.
Okay.
Yes. Sir.
Polygons, depending upon the number of sides, are given a name.
Sir, can I
First,
call this a polygon, sir? Sir, I
which
draw
one?
a straight line
Hmm.
and a curve, a straight, and attaching a line to the curve and another curve and another
Like a
straight line.
semicircle.
No. Like, so can you just keep drawing as I say, sir? A line, like it's
Okay.
really complicated shape.
Okay.
A line, a curve.
Where? A curve where?
Okay.
Not that type of curve, sir.
Okay.
Like a perfect curve.
Okay.
It should be like a. It should be like
It's not
You
a
hexagon.
still
polygon.
draw
It should be like a hexagon, sir. But there will be 3 lines and other 3 are curves.
Okay, got it.
Is that like?
So, but how do you understand what Sankalp is saying? So I can't understand if he's normally talking also, sir.
Like this?
Yes, sir. Yes, sir.
Oh my god.
Oh my god.
Yes,
So you got
Okay.
that from
So it's not a polygon.
sir. But it's following all the rules. So it's a closed plane figure
No.
bounded by 3 lines.
There's a curved line.
Line segments.
It should be line segment.
Yeah, it is a line segment.
No, a curved thing is not a line segment.
It is.
Yeah,
The curved one, sir. Oh my, okay.
Yeah.
Three
yeah,
line.
but there are 3 line segments in it.
It should be bounded by 3 line segments.
Oh, let's speak.
I don't know, sir. You continue, sir.
You know, there is I mean, I should say, actually, this definition is not appropriate. Okay. Bounded by at least 3 line segments. It should, if that is the definition, then this is a polygon. However, it is not. Correct definition is, which I was also going to point out, correct
Broke the
definition is
system.
where
Three straight line.
the figure is bounded by all line segments. Okay. Closed plane figure bounded by all segments which are lines, which are line
Yes.
segments. So then it will make a polygon.
Yes, sir.
Sure. So
Sorry, it's
there is
not
a
Sankalp.
correction here. Okay, fine.
We'll report the author.
Yeah. So then, when we have different line segments, depending upon the number of sides, we have names also. We give 3 sides polygons as triangle, 4 sides as quadrilateral, 5 sides pentagon, hexagon,
hexagon.
heptagon, octagon, and so
That's
on
all.
so forth.
Is there algebra in this chapter?
Yes,
There will be
somewhat,
X, Y, and Z.
somewhat.
Okay, sir.
Okay. Now, in polygon also there are 2 types of polygon: convex polygon and concave polygon. Convex polygon, so basically, have you seen in physics convex lens and concave lens?
Yes, the
Not lenses,
sir.
but mirrors.
concave is like this.
Not lenses,
Mirror.
but mirrors.
Mirrors we have seen. So this
Like-
mirror is called as what?
Sir, it's
Convex.
Concave.
Convex.
concave.
Concave. Ah, okay. Yeah.
And this mirror
It's
is
concave.
convex.
It's
Convex.
Why is that so? So
Sir,
the meaning is
concave mirror,
It caves
like
in. Concave caves in.
concave mirrors, they diverge
so
all the light rays,
yes,
and
when we
convex, like,
fall,
they
when
converge.
we make the rays fall on the mirror,
yeah,
they
we
come
converge.
inside. They come inside.
converge.
So let's use the word inside. Okay.
Ah.
And when I fall the rays on the mirror which is convex, they go
They go
outside,
outside.
Diverge.
right? So we'll
Yes.
use the word inside and outside. In polygon, when each angle of a polygon is less than 180 degrees, then what happens? Any 2 points,
Each polygon is less than 180 degrees.
no, each angle of a polygon. For example, this
It's
polygon
not
of 4
convex.
sides, correct?
Oh, I get it, sir.
Each of the
It's not a-
internal angle is less than 180 degrees.
Oh,
So
180
it is a
straight line.
concave polygon. Sorry,
It's a convex.
convex. Just a second. If
But
each
this-
angle of a polygon is less than 180, it is called as convex polygon.
Sir, but one that's more than 180 degrees is not even a polygon, right? Oh yeah, it's a polygon only. Oh, it's like,
It is
it'll
a
be like
polygon. It is possible.
it'll be I mean, you can't even
It's
really
like-
name that shape.
Now we can make like this.
Yeah,
Can't
that's
really
what I
name
was
that
talking.
shape. Yeah, we can't really name that polygon.
This is a polygon having 1,
Did
2,
they
3,
ask you
4,
for a name?
5 sides. Okay.
Oh, what is wrong with you, Rakungu?
So this is a pentagon. Okay. In this,
We can't name it. That's
one angle is more than 180 degrees.
Okay.
Okay. So this is a concave polygon. Okay. Now, most often, when we use the term polygon, we always mean convex polygon. Okay. Give me a second here. Give me a second.
that looks like a landscape, like the sun
What?
behind mountains.
Of all your drawings. All
There's
your
a
drawings
pond.
in one picture right there.
There's a road.
There's a road. I don't see no road. Oh, it's a
Understood?
road into the sun. That's what
So most often, a polygon will always mean convex polygon. Okay. So after these naming ceremonies, moving on. Now this is an interesting part. It says that in a polygon of n sides, the sum of all interior angles
Hey, we did
is
this.
equal to 2n minus 4 right angles.
So we did this last year. I
basic
think.
mathematics.
I think.
Basic
Yes.
geometry.
Yes, it is a very basic
So we
mathematics.
did 2n minus 2 180 degrees.
I,
So it's
I
the
think
same.
Same thing.
we're gonna
It
do
is or n minus 2
formula.
180 degrees.
Yes, sir. This is the formula that we learned.
Yeah, right.
No, I like
Very
the 2
good.
and minus 4 better.
Yeah, that's
Now
that's like
another
Okay,
thing
shut up.
looks
also you
simpler.
should have
Okay, shut up.
another thing also you should have noticed that exterior angles, okay, in triangle it was very natural to see if this is an interior angle, then exterior angle is this.
Yes,
Yes.
sir.
But in polygons, we have to be little careful. So the general process is that we have to extend the lines which
But
are
is it a
making
triangle
the
also a
polygon.
polygon?
Triangle
And
is
the
also
bottom.
a polygon. So what we do, see, this also I can extend, this also I can extend. So first I did this, and did this. What is the direction? Anti-clockwise direction,
Yes,
Yes,
sir.
correct?
sir.
Yes, sir.
So we extended the line segments in the anti-clockwise direction. So it
Yes,
is
sir.
saying that if the sides of the polygon are produced or extended in either direction, clockwise or anti-clockwise, but all in the same direction,
Sir, this
the
is clockwise,
sum,
right, sir?
I
No.
did first this,
And then the
second
top
And
one.
this,
then
Okay,
that,
okay.
and then
and
that
third.
one.
Yeah. Okay. The sum of exterior angles formed is 4 right angles, that is 360 degrees. This also did you see in your last classes?
Yes, sir. Yes, sir.
Yes, sir.
So it's
Very good.
360, 480, and then it goes
No,
on.
exterior angles are not 480 or stuff. All exterior angles are 360, but interior angles are
Yeah, interior
360,
angles is my bad.
180, 360,
Very good.
550,
So
something.
sum of all exterior angles is
360.
360 degrees. Okay, excellent. Next. Now comes to regular polygon. Regular polygon by name are those which has all its sides equal to each other. They should be of same measure. All interior angles equal to each other and all exterior angles also equal to each other. So a polygon, regular polygon of 3 sides is called what?
Um,
So regular triangle,
triangle, triangle.
equilateral triangle.
Equilateral triangle, yes.
Okay.
A
Regular
square.
polygon of 4 sides is a
A
square.
square.
Right. Like that happens. Okay. This you have seen already.
Hexagon,
Also you have seen already. So at
But
each,
for the two,
so say
suppose for the
this, let's say this happens to be one vertex of a polygon. I want, now this is a common observation that this when produced gives this as an exterior angle,
yes, sir.
and
Yes, sir.
the internal one is an interior angle. What is the sum of interior and exterior
It's
angle at
180,
every
180.
180 degrees,
180
the
degrees.
straight line.
So exterior and interior together makes 180 degrees at every vertex. Okay. Now, if I have a regular polygon, at every vertex, internal angle is same, interior angle is same, exterior angle is also same. So each interior angle is together now using the same 2n minus 4 right angles or n minus 2 180 is this thing. N sided regular polygon. How many angles it will have?
It'll have n sides.
It'll have n,
Angles. How
n,
many?
n
How
minus,
many
it'll have
interior
n
angles?
angles.
It'll have n
So
angles.
n interior angles, right?
Yes, and
Yes,
n
sir.
exterior angles.
Each of
Sir,
them are
can
of
we
same
call it an
measure.
exterior angle by if we do not draw that imaginary line and just draw the angle, is it also an exterior angle?
Yeah, but where will it end?
No.
No,
Who are you calling? Who are you calling as exterior?
sir, erase that green line and connect that other line to other line without drawing that green line. It will also create an angle, right, sir? That is also an exterior one, right?
It'll be a
That'll
whole
be a
round
So
reflex
in
there,
that
angle.
in
basically.
in in that case, You are also right. In that case, you would have done all the extensions in the clockwise direction.
Same thing.
No, sir. Like he's asking like an entire thing.
You are asking this whole thing.
Yes, sir. That's also an
That'll
exterior
be
angle, right?
360 degree.
No. That's what I'm saying. This is not considered as exterior angle.
This outside, right, sir?
So we have to
But it is
be
not exterior.
following the terminology in the way it is given. Yes, it looks exterior because exterior by psychology should be bigger, right? And interior should be smaller. But think of it in this way. Can I not have a polygon whose interior angle is bigger than exterior angle?
You can.
Yes. What if my polygon is part of like this? Then who is interior, who is exterior?
The interior is exterior and exterior is interior.
Interior is bigger than
What?
exterior.
Yeah. So we have to follow some convention in which interior and exterior angles are fixed.
So in this case, the interior plus exterior will be 360 degrees, sir.
We were following that
Yes.
notation, but we are following this method. Okay.
Sir, so people used to do that also.
Yeah.
People down.
So at some point we have to follow certain method, certain rules, no?
The limitation to everything.
Yeah.
Soon people will find limitations to this also.
Okay then. So then, now this is the measure of each interior angle of a regular polygon. Either this or n minus 2 into 180 divided by n. The interior angle of a regular polygon having n sides is of this measure.
Sir.
Exterior angle of regular polygon also can be calculated because previously you have seen sum of all exterior angles is 360 degrees.
360 degrees.
All exterior angles have to be same measure, so they are in proportion.
So does that mean we can just, for the interior angle of a regular polygon, we can just count the number of sides and then just like count the like all interior angles in the sense that if a triangle means 180 by n itself, we'll get all interior
Yes.
angles.
Yes, all exterior angles.
If for interior angles also we can do. If it's a square means 360 by n. If
Yes.
it's a
Yeah.
hexagon means 540
So
by n.
having only the information on the number of sides of the regular polygon, we can
Is enough
find
to find everything.
interior angle as well as exterior angle. It's like that.
Yes, yes.
And also vice versa, that somebody tells I have a polygon of some number of sides which is regular. Each interior angle measures this much. Can you tell me the number of sides? That also can be found.
Oh yeah, I remember in 8th grade we got questions like this.
And this is what your fifth point is. If each exterior angle is x degrees, the number of sides in it is just 360 by x.
Oh, this is
Because
the type of question you just said.
yeah, so relationship is like this: angle A, which is exterior, is 360 by the number of sides. So either you write angle A equal to 360 by 9 or n equal to 360 by angle A, both are same things.
So then what about the like find the number of sides if one of the interior angles is given?
Then it is like this. So if angle B, which is interior, I can write it as n minus 2 into 180 divided by n. Now I have to solve this equation. If I'm given the interior angle, it will be a linear equation. So you just have to solve it.
So just swap n that side.
Yeah. So this will
And
be n multiple
It
of
will be
n,
minus b.
and it will be 180 into n minus 360. So take one side
So
other.
it'll be 181 n is equal to 360
Understand.
by n.
It will
Can
be
you just
n
show?
times of angle B, 180 n minus 360, and that will be 360 equal n into 180 minus angle B. N becomes 360 upon 180 minus angle B.
Whatever angle B is,
So
we subtract it 180 and then divide it with 360. And you get number of sides. Okay.
So angle information and sides information of regular polygon are easy to find if one is available. Okay.
Yes, sir.
And this is just a common understanding that greater the number of sides in a regular polygon, greater is the value of its each interior angle, and smaller is the value of its each exterior angle,
Yes, sir.
because
Sir,
it
you
expands.
know, we know like the sum of all interior angles of a hexagon is 720 degrees, right, sir?
Yeah.
Sir, is it possible to draw that angle, sir? Like,
this, it's a sum.
It's a
yeah,
sum.
like,
It's
no, I'm
not.
just
You can,
asking, is it possible to?
it is possible.
What do you
You
mean?
can use protractor also. So
No, sir.
it's possible.
What do you mean? There's 180 degrees on your protractor.
No, but I'm talking about 720 degrees.
It's
No,
a sum, not
360
a
degrees is
single.
the maximum. No, he's asking if does this angle
I'll tell
720
I'll tell
degrees,
you.
is it possible to draw?
I'll tell you. It is like this.
Add it.
You want to draw 700 degrees, let's say. Okay. So how much it is 360 degrees
So
plus how
360
much?
times
360 plus
plus
340.
240, right?
340. 240.
Oh,
So
sorry.
Yes,
what I
sir.
do,
Sir,
I
Oh,
take a
340,
line,
sir.
no, sir,
It is
340, sir.
340.
340. Okay,
340.
great. So what I do, I take a line segment. This is how much?
360.
360.
340
340.
degrees.
700.
This is
How does that make
700
sense, sir?
degrees.
It makes as much
What
of
do you mean?
sense as your
360
question,
is the
da.
max. 360 is one round. 360 more than
So
360 is
No,
like
it makes
more
so
as
this
rounds.
much as sense as
happens.
your question.
It is
Stupid
because
question,
it is
stupid
making
answer.
sense because
This
see
is a smart answer.
the multiple of 360 degrees is a revolution around the vertex point. Okay. So by saying 700 degrees, I mean I first rotate around the point one complete revolution, and as I come under the radar of 0 to 360 degree, I make that.
Okay, sir.
It's like our Earth. So it
Maybe
takes.
it's possible to draw it, but like we can inform it that this 700 degrees by drawing it and telling everyone this is 700 degrees and we have to follow it. But is it possible in real life?
This is the
700 degrees.
thing.
No, like
It is this is yes, it is.
It's like our Earth. 365 days, we will have like one revolution.
What?
If we ask like 700 days means we will have like
We
1.5 or something like that.
exact. You call it a month, no?
Yeah.
How do you call it a month? How do you call a year, by the way? One
Sir,
365
revolution,
days.
1 year.
around the
but
sun.
sir, but is there an object in this universe which has like 720 degrees, sir?
Days, Uncle,
720 degrees.
stop it with your
What
unrealistic
you used
doubts
to
and
say
No,
like
like
this was
hypothetical
720
cases,
degrees.
please, da.
This is 720 degrees. 360 degrees is the max. After that, it goes back to zero. But like we take the 700 degrees Celsius. There's nothing called 700 degrees Celsius straight line.
Okay, I'll give you a
degrees
straight example.
Celsius.
See, it's not that it's not possible or possible. It's not a question about that. Okay. The question is it helpful to understand something?
No.
No.
Degree, the word degree was invented. Okay. Why it was invented? To understand this revolution system. Okay.
Yes, sir.
Even in the clock, one revolution is of 12 hours. After that, you call it 1300 hours also, but you also call it 1 hour. Correct, no?
Yes, sir.
After that, you call it 24 hours. Then what? Do you call 25?
No.
So we called it 1.
You call back again. So it is a system which helps us to understand few things. Okay.
Yes, sir.
Not every time, always everything has to be unique. 700 degrees is same as 340 degrees. That's all. Getting the point?
Yes, sir.
Yes, sir.
Yeah.
Sir, yeah, it is.
Hey, I'll break
It,
your.
it is.
I'll
They're
It is.
actually like, come
It
to
is
your house
same
and
as
call
340
FBI.
degrees, sir. But it's 700 degrees is not possible. Like to draw it.
No.
How was it? Like, use your common sense, no?
We assign the meaning of 700 degrees to be 340 degrees. And it is possible to draw 340 is 700. That's all. It's just another name. How many names do you have at home?
Kalpaj,
Donadola, Anand, Sankalp.
Donadola,
Sir,
Kalpaj.
lots,
There are many names now.
Yes,
yes,
sir.
sir.
So should I say that is it possible to call both these persons of these names? Give me your name except Sankalp.
Palkaj.
What's the Kalpaj?
Kalpaj.
Kalpaj.
Yes, sir.
Kalpaj.
So
Dornadola.
so can Nitish bring me Sankalp and Kalpaj together in front of me? What
No,
will you
There's
say?
actually a guy named Kalpaj in 12th, sir.
Okay. Okay, not Kalpaj, sir. Dornadola.
Nadula.
You can't bring back my ancestors, sir.
I don't care.
No, but the point is this. See, you will say the same thing. No, they are both names of the same person. Then how can I have two persons? It's
I
just
bring
that.
one Sankalp, 14-year-old boy from 9 Sisha,
And
and
one
one
Kalpaj
Donadola
from
from 9th
14-year-old.
grade in Chennai. No.
Okay, so moving
Just
on.
different names for same thing.
So small basic questions we will cover. Can you try this one?
No, I hate it. The sum of interior angles is x.
Only information which we need from previous slides
So don't we need
is
a
the
number?
relationship between interior angles measure and exterior angles measure.
Sure.
Okay. The sum of
Yes, sir, I'm
interior
done.
angle always 2n minus 4 right angles. Sum of exterior angle is 360 degrees.
I found the answer.
Hey,
What
shut
is
up now.
that?
1 second, sir. Don't.
Can I tell?
No, wait.
12.
Yeah, tell.
No.
Very good. Okay.
12.
Let n be the number of sides the polygon. Okay. Then it is saying the sum of interior angles is 5 times the sum of exterior angles. The exterior angles is always
360.
360 degrees sum, and this is 5 times. This measure is the sum of all interior angles. What is the sum of all interior angles? N minus 2
Minus
into
2 times 182.
Yes, sir.
180.
So even I got it. Okay, 9.
Correct.
12. 12.
So it means n minus 2 is equal to 5 into 360 divided by 180.
That's 5 times 2.
It's 2. N minus 2 is equal to 10, which means n is
N
equal to
equals
12.
12.
That's all. Okay. Next question. Try this.
One angle on each side of doesn't equal to other angles are equal. So other angles are other than 100 degrees unequal.
Yes.
So we'll have 8 angles. Out of that, 1 is 100.
It's not a regular polygon.
No.
What's that sound?
This is this is easier than I thought.
Well, wait then.
Yes, sir. Done.
No.
I'll put the answer in the chat.
So let X
That's
be
140
Hey,
degrees.
140 degrees.
measure of
Mhm.
other 7 equal angles. What I know is sum of all interior angles is
1080.
n minus 2 into 180. So n is 8 here minus 2 into 180.
180.
So
6
only
times
one,
180.
yes. So
1800.
100
1080.
plus 7x is 6 into 180, that is 1080,
Yes, sir.
which means 7x is
1080
980
minus 100 is 980.
and
X is
x
equal to
is equal to
980 by
980
7.
by 7,
It is 140.
which
140.
is 140 degrees. So the measure of other equal angles are 140 degrees. It also tells us much more. If somebody asks, is it possible to draw a polygon in which all angles are equal except one?
Very much
It
So
is.
answer
possible.
is
It is
yes, very much
possible.
possible. Likewise, I can also ask, is it possible to draw a polygon in which all angles are equal except two angles? What do
Possible.
you think?
Yes.
So that
If
2 angles should be same.
could be two cases, same or different.
Oh, okay. So in any case, it's possible.
So that's what the point is. Third question. Try this.
AB is parallel to EB. B is parallel. Well, this is a five-sided figure. No, wait. Five-sided figure. This one is parallel. Sir, this angle E and angle A 90 degree. Sir, this angle E and angle A 90 degrees?
Not necessary. Not to scale. I can, even if they are not 90-degree, I can tell about the sum of A and E.
Sum of A and E are 180 degrees.
Oh, oh, okay.
They have to be 90 degrees.
No, not necessary. It could be like this is 89, this is 91. It looks 90, but it's not.
Answer.
Wait.
Can I tell the answer?
No, wait, Ral.
Sure, can I tell the
Oh.
answer?
Oh, wait. Angle A plus angle E is 180 degree because
Oh.
because AB and ED are parallel on their like transversal stuff.
Sir, I want to tell the answer.
No,
Yeah,
wait.
yeah.
No.
Sir, C is 100 degrees and
Mhm.
D is 120 degrees.
Okay.
Sir, 2 seconds. 2 seconds. Sir. Don't do it. Like, I'm almost done. Sir. Like, I'm so close.
I told the answer. What's the point?
I got it. I got it. Can I tell my answer?
Tell.
Sir, I got. Okay, nothing. I don't have my answer. It's wrong.
So sum of all interior angles of a five-sided polygon is 5 minus 2 into 180.
540.
Now this one being parallel, AB and ED are parallel. They are all which type of angles? A and E?
Supplementary
They are
angles.
Supplementary
what?
angles. And the sum of
Oh,
supplementary
supplementary.
angles is
8,
180 degrees.
180.
180.
So this becomes
I thought sum of
11x
supplement.
plus 140 degrees.
The sum of
And this
supplementary
is
angles is 180
5,
degrees. Sum of complementary angles is 90 degrees.
90. Yeah.
so 11x is equal to 540 minus 140 minus 180. So
So that's
540 minus 140 is
400 minus
400
180.
and that is
That is
220.
220.
Uh,
So
I
x is
Pongal, how down?
20 degrees. Therefore, angle C is 5x, meaning 100
100.
degrees, and angle D is 6x, meaning 120 degrees. Okay, good.
Pongal, please,
Try this
can
one.
you home tuition me?
I have to leave the tuition now.
No, I know.
I'll give it uh, to you as a homework. Keep this
One
with
point.
you. Take a screenshot.
So,
Okay.
I took a screenshot.
Move on. We'll move on to the next thing.
is Uncle sleeping?
No, he's eating.
Hello, Sankalp.
No, I'm speaking. I'm
Mm.
eating.
Sankalp not listening to class. Very bad.
Hey, Sankar, taking Tarun's place, sir.
Yeah.
Okay. So
I was wondering why the class was
small
silent.
thing. Now we move on to quadrilaterals. Okay. A general quadrilateral is a four-sided polygon,
Closed figure.
closed figure, closed plane figure bounded by four line segments.
A quadrilateral is not a regular polygon, right?
Not necessary.
Okay.
Every regular polygon of four sides is a quadrilateral, but not the convex. Quadrilateral has four vertices and two diagonals. And as you know, four-sided figure, sum of all the angles, interior angles is 360
60.
degrees.
Yes, sir.
Now we move to specific type of quadrilaterals and see some properties. We'll see trapezium, square, parallelogram, rectangle,
So we learned it
rhombus
in
and
8th
all
grade.
everything. So just a small uh,
No, I don't like trapeziums. They're so
Very
confusing, sir.
annoying.
small
No, it's fine.
refresher. Trapezium is a quadrilateral in which one pair of opposite sides are parallel and the other are not parallel.
But equal?
Not necessary.
Then why is there a picture given it's equal, sir?
It's wrong, right? That's what I was also saying. It
So
doesn't have to be
ideally
equal, right?
the picture doesn't have to be equal. Ideally the picture should be like this.
So it's wrong, right?
I mean, it can be equal, right?
Can
It
be,
can be, but generally it is not.
but they've
Generally,
Trapezium
given
what?
it's
is
equal,
not,
sir.
see, trapezium is not measured by
Oh, sorry, sir.
the
It's trapezium. My
sides
bad, sir.
of
Sorry,
the
sir.
length. It is not measured by the sides length. Rather, it is measured by parallel sides. So
So I
where,
saw the isosceles trapezium diagram and I got
yes.
confused.
Oh,
So,
that's what I also saw.
so with trapezium, you think in this way: parallel and not parallel. Okay,
Yes, sir.
one pair of sides parallel, other pair of sides non-parallel. That figure is called as trapezium. Now, in which the other sides which are not parallel, if they happen to be same length, then it is called as isosceles trapezium.
So the opposite sides are equal, except the parallel side.
The sides which are not parallel, if they happen to be of same length, it is called as isosceles trapezium. Okay.
So this is the one that's generally not given.
Yeah.
So
We
because it will
generally
make it
deal
as
with
easier,
general trapezium like this.
so it'll be harder for us.
It
Yeah.
actually there's no properties for it. Adjacent angles are supplementary. That's it.
That's for everything, right?
Yeah,
Next,
trapezium is
parallelogram.
like father, grandfather.
Parallelogram, in which both pair of sides which are opposite are parallel. So in this case, we put the picture as this one. Opposite sides are parallel. Now there are many properties for parallelogram.
Parallelogram is the best.
Opposite sides are parallel. Opposite sides are equal in length. Opposite angles are equal. Consecutive angles are supplementary.
Oh
That
my god.
means A, B, this one, A and B interior, okay? They sum to 180. B and
180.
C 180, C and D 180, D and A 180. Can you tell about B and D? Are they also 180 degrees?
So
Yes.
because B
No. Oh,
and
wait.
A are
They're equal,
same,
sir. They're equal.
They are equal, but they are
180 degree.
not
What?
necessary 180
Yeah,
degrees.
they're equal.
So but
That
angle
means
D
that
and angle A are 180 degrees, but why angle D and angle B? Because angle B and angle A are same.
Angle B and angle A are same, and they sum also to 180 degrees. So only adjacent, the consecutive angles, they sum to 180, but the opposite angles, they do not sum to 180. A particular example, look at it in this way. I'll draw a very sharp parallelogram. Is it a parallelogram?
yes,
Yes, sir.
sir.
Very small, very small. Can the sum be 180?
No,
No, sir. Not any
Very big,
chance.
very big. Can the
Yes,
sum be
sir.
180?
no,
No,
No.
it'll
no,
be
no, no. Hell
more.
no.
So
No way.
Why is it
opposite
more?
angles
It's
do
still a
not
parallelogram.
sum to 180 degrees always.
But adjacent angles too.
Adjacent
I
angles,
hate adjacent.
that is consecutive. Now another property is that diagonals bisect each other in parallelogram. Each diagonal divides the parallelogram into
Into
two congruent triangles. Okay.
even in that narrow
Yeah.
Yes,
parallelogram
even in that. This means this yellow region,
is equal to the green region.
the blue region.
Okay. So why do you dislike
Okay.
green so much, sir?
And likewise, no, I don't dislike nothing like that.
It's just ugly color.
No. All colors are good.
Yes, sir.
So other property is, now each diagonal together divide the whole parallelogram into four triangles. They also happen to be of same measure in area. Okay.
Yes, sir.
But that is very interesting because
Like both the triangles.
in all four, in this case, the flattened triangle and a little less flattened triangle, they are of same area.
All four.
All four. These like this.
So in that
Okay.
isosceles, I mean, no, in that big one, DOC, COB, everything has the same area.
Yes. Same area.
But it
Yes.
looks like COB is smaller, sir.
Looks like that, but what we perceive may not be always correct. Okay.
You have a lot of life lessons.
Yes, very much.
So take
Let's,
the benefit.
yes, very beneficial.
Okay, next.
Next.
Rectangle, most easiest one.
Yes, there's nothing left.
Yay.
Rectangle is a special parallelogram in which all diagonals. So parallelogram where each angle makes 90 degrees. Okay.
Sir, does
So
this
parallel,
polygon also
parallel.
have the same property of all triangles formed there or have same area?
Yes. What is true
Yes,
for all parallelograms is also true for specific collection, particularly rectangles also.
yes, sir.
So in rectangles, diagonal bisect each other, they are equal, and each angle is a right angle triangle.
Next one easier. Where?
Next is rhombus.
Ah,
Rhombus is a parallelogram in which, so
all sides are equal.
all sides are equal.
So, but in the picture, it looks like opposite sides are parallel.
Because it is a parallelogram.
It's
So
also
all
parallel.
sides equal and opposite
Op-
sides parallel. Okay, that is called as rhombus.
So then, isn't it just a isosceles parallelogram or something like that?
No, it's just a rhombus.
Okay.
Okay, so in this, all sides are equal, diagonals bisect each other at 90 degrees, and each diagonals bisects angle at the vertices also. That means these angles are same.
Yes.
In fact, it happens in general parallelogram also. Okay. Then square, most easiest one. All
Yes.
four sides same length, opposites parallel, angle 90 degrees. So if
Yes.
we were to draw a picture, so most of them, I have told you 5 names, right? One
Yes, sir.
trapezium,
Trapezium.
parallelogram, rectangle, rhombus, square. So
Yes, sir.
parallelogram,
Is a stretched out square and slanting.
Not
parallelogram
necessary.
has a subclass rectangle. Okay, rectangle has a subclass square. Okay,
So I thought
rhombus.
square
So
was like
can you tell
separated.
how to put rhombus?
Parallel.
Trapezium
It's
is
above
another
parallelogram.
above parallelogram. Mhm.
Yes, I think.
In rhombus, what happens? It is a type of parallelogram.
Where all
All
sides are equal
sides are equal.
and the bicep. mm, The diagonals form intersection of the diagonals form 90 degrees.
Mm.
Yeah.
So a specific type is rhombus.
Oh, no.
Okay.
So even in parallelogram, like the diagonals bisect each other at right angle, right?
No,
Oh yeah, sorry, my bad. No, my bad.
Not
not
necessarily.
necessary.
Yes.
That's why it is a special class of
So,
parallelogram.
So
Okay.
does that mean trapezium is above all?
No, it's not. Nobody is above or below. They are different classes, different pockets.
trapezium is the grandfather.
You can
Parallelogram is
think
like a
of
father. Everything
whatever you
else
So
is like
want to
a
square is
say.
son.
like the grandchild.
Rectangle
Trapezium is
and
a
rhombus
neighbor.
are its son.
Trapezium is a
Yes,
neighbor.
sir.
parallelogram grandfather, rhombus rectangle children, and square grandchildren.
So trapezium's neighbor. Trapezium doesn't come under this.
Neighbor. Triangle
Hello,
is
neighbor.
part of the child.
Circle be like across the country.
Yeah. Okay then. So other things we'll see in next class.
Yes,
So
sir. Thank you,
Sankalp, I
sir.
don't know
Bye,
what
sir.
Sankalp was doing, sir.
Yeah, Sankalp got caught.
I mean, he
Very
didn't
bad
get
boy.
caught. He was just not.
He won't
Okay.
leave. See, he'll be there in the meeting till the end.
He'll end after sir leaves, I think. Yes, sir. Thank you, sir. Bye, sir.